and welcome to today's webinar. On behalf of International Airport Review and Dassault Systèmes, I'd like to thank you all for attending. I'm your moderator, Tara Nolan, Editor of International Airport Review. Today's speaker is Dirk Jekkers, Senior Solutions Consultant at Dassault Systèmes. Following his presentation, we will then move on to a live question and answer session where you can post questions to Dirk. You can submit a question at any point during the webinar using the questions panel situated in the menu on the right. I will now pass over to Dirk.
Thanks, Tara, for the introduction. My name is Dirk Jekkers, and I will be talking today about optimizing the passenger flow at the airport. It will take approximately 30 minutes where I will explain the concept and the techniques that you can use to optimize the passenger flow. And by the end of the session, I'm happy to answer all your questions. I'm also curious about your feedback on the presented topic. So let's get started. So let me start with the key takeaways. So typically we would do that by the end of the presentation, but I just want to give you a bit of an idea what are the questions we're going to answer. So first, after this presentation, you should understand that each decision we make in our resource allocation has an impact on the downstream processes at the airport. That we can use a flow model to get visibility of that impact. And once we have that visibility, that we are capable of allocating resources in a much smarter way to optimize the passenger flow in a cost-effective way. So we will start by explaining what our definition is of the flow. Then I will show you an example of how the downstream impact, and what that means for your overall passenger flow. And then we dive into the concept of a flow model and using that to understand your service levels and your capacity needs. How you can use that model to monitor the flow, and how you can use that model to make smarter resource allocations. So to start with the passenger flow, what is our definition of a passenger flow? When we look at this picture, it's a schematic of an airport where people will enter the terminal building and they will leave at some point the terminal building again. And in between those 2 points is the passenger journey. So there are different journeys that we distinguish. First of all is the departing passenger. So these are the passengers that arrive at the airport, maybe via taxi or public transport, and they will go to various checkpoints or touch points in the airport to go to their departing plane. The second stream is the arriving passengers. So those are the passengers that arrive at the airport, and they will go to immigration, pick up their baggage, go to customs, and in the end leave the airport via onwards travel. And the third stream is the transferring passenger. So those are the passengers that arrive at the airport and they have to get to their departing gate. When we move, for example, from a domestic to an international flight, that means that this passenger would also need to go to additional checks like the immigration or maybe also security. And in between there could be a shuttle service that brings the passenger from one terminal building to the other. So these are the 3 main passenger journeys that we distinguish. And during that journey, the passenger will experience a certain service level. And he has also some expectations on that service level. And so when we talk about the passenger experience, we're talking about the waiting times and the walking distance, whether there is enough space available in the lounges or whether there are sufficient retail facilities, whether there are enough service employees, and whether a connection is easy and can be made. But also at the end of the journey, so we look at whether there are sufficient taxis available or parking space available. So basically, in each of the touch points that the passenger has in the airport, there is a certain expectation that contribute to the overall passenger experience. So when we combine all the passenger journeys of all our passengers in a certain time window, and we look at their overall passenger experience, and that's when we are talking about the passenger flow. So that's the combined journeys of all the passengers through the airport and their experience in it. So why is monitoring the flow important? Because if we don't monitor the flow, we see typically a few problems arising. And the first one is that we have unexpected queues. So typically you would plan for a certain demand, and with that plan you should, your queue should be within an acceptable service level. But if you don't understand the flow of the passenger, it could lead to queues arising at moments and at touch points where you were not expecting it. It could also mean that you have congestion in parts of the terminal building, where in other parts there might be enough space. And thirdly, you could have insufficient staff at certain touch points at certain times, while at other touch points the staff is idle. And these problems then lead to, most of all, an unhappy passenger that has to wait at the touch points and doesn't feel to be treated on the level he is expecting. Worse, people could miss their connections in such a scenario. But also your staff has to operate in a more stressful environment when the passenger is unhappy and feels they're not getting the right attention. And that then could lead to higher cost, because to prevent those things, or when they happen, we typically solve them by having people working overtime to handle this additional demand. Could also lead to loss of retail revenue, because people are spending more time at the touch point and less time in the departure lounge. Or it could lead to penalties when you have agreed to a certain service level and you're not meeting up to that level. Penalties could be involved. And these all arise due to basically two main factors. The first one is the uncertainty in the flight schedule. So we know that, we can plan a perfect flight schedule, but in operations we see delayed flights, we see flights arriving earlier, we see cancelled flights, we see gate changes, and all of these have an impact on how passengers, when they arrive at the airport, and how they move through the airport. And second one is the passenger demand themselves. So when will they show up? That could have been influenced by traffic jams on the onward or the inbound travel. Could also differ by the type of passenger, or the type of period in the holiday period might be different than outside. And the second one is that we do not have visibility in our upstream and downstream processes. And that is exactly the topic that we will cover today. So how a flow model can give that visibility in upstream and downstream processes when we are allocating resources. The first one is also important. There are various forecasting techniques available where you can better predict your passenger behavior and where you can better predict how a flight schedule is being executed. But those numbers are input to our story, and we will look how you can use those numbers to better predict how your passenger is moving through the airport. So let's first want to make a distinction between having a holistic view on your airport and the siloed view that we typically see. So what happens when we see that there is a problem at one of our touch points? The first step is that we identify there is a problem. That could be by passenger input, where we can see that on every Monday morning people are unhappy at a certain security area. More likely you have monitor software in place and sensors that can actually measure the current queue lengths and can also identify patterns and when these problems will arise. So first we identify the problem, and then we try to solve the problem in that area. So when a sensor lights up and says the queues in security area 1 are getting too long, and the typical reaction is, well, let's open an additional lane. So that is what we do on the short term. But then if this is repetitive, this problem, then we try to prevent it in the future. So we look at the historical data, we look at the resource plans that we have in place, and we try to find where can we increase the capacity such that we do not hit these problems each and every time. But how we look at those problems is really at a single silo. So it could be in security area that does these kind of research, could also be at immigration or in the retail. But we are not talking to each other when we are updating our plans. So let's see an example of what that could lead to when we are just making a silo decision. So we go back to our passenger passenger journey, and we're looking at a passenger that is going to board a plane at 3:15 at gate 25. And this passenger arrives at the airport approximately around 1 o'clock. So this passenger has to go through a series of checkpoints, or touch points, and he will notice that at the check-in the queues are acceptable. At security, it's the Monday morning, so there the waiting times are actually too long. Immigration, it's not busy, so he can quickly move through that touch point. So when we look at this in the siloed way, we would start maybe to increase the capacity at the security such that this passenger journey would be improving. So let's open an additional lane here at security. And indeed, the waiting times go down at this particular touch point. But as you probably already guessed, what that could lead to is that at immigration, now the wait time is starting to increase. Because security is now processing more passengers at the same time. That means that at immigration, they have to process also more passengers to stay within the service levels. So if you just increase capacity at security while not looking at immigration, that could end up with the passenger still has the same process time until he or she reached the departure lounge. So what we actually have done, we have increased the cost by adding additional resources at security. However, the overall experience has not improved at all. And maybe even worse, when we look at another passenger's journey that makes use of the same touch points. So here we have a connecting passenger that has to go through immigration, and he had a very tight connection already. But because of the decision of increasing capacity at security, this passenger now, this transferring passenger now has to wait longer at immigration, and therefore could miss his connection. So again, when we look at a siloed approach, we might not even improve the service. We could even make it worse for another group of passengers. So what we're proposing in this webinar is that we should not look at those touch points individually, but look at all the demands at our touch points, and also understand the impact when a decision is made in one touch point, what that means for the demand in the next touch point. And that is what we call the holistic view of the resource allocation. So look at it from look at the airport as a single system, where there are small subsystems that all influence the performance of one another. So let's dive into our proposal and of using a flow model to circumvent these kind of situations. So first, what is a flow model? And when I think of flows, I typically think of a water flow. So water, in this picture, for example, in the mountain that tries to go from a higher region to a lower region, and it typically takes the route with the least resistance. So let's start with explaining a flow model with the use of a water example. So at the start of a water system, we have a source. This is where the water enters the system. And at the end of such a system, we have a sink. This is where the water leaves the system. And everything in between is in the water system that we can control in our flow model. So we have reservoirs. This is where water can be held for a period of time. And we have taps that control the volume of inflow and outflow of the water. So the more open I make the tap, the more water goes through it and will therefore increase the inflow of water in the next reservoir. And then we have pipes in the system that actually control where the water goes to. So we have this water system. Now let's see what we can do with it. So we can open a tap and then water starts to pour into the first reservoir until it hits the next tap. And here we have a choice which tap to open to steer the water into a certain direction. But if at some point the inflow of water in one of the reservoirs is larger than the outflow of water, you end up with spillage in a certain reservoir. So what we do with this flow model is we try to bring water from the source to the sink in the most efficient way without any spillage of water. Okay, let's transfer that concept to our airport and to the passenger flow. At the top we have the source. In this case, these are the passengers that are entering the terminal building, either by an airplane or by another journey, like in public transport. And they go through the system until they reach the sink, and the sink is in this case a departing flight or when they exit the terminal building. And in between we have queues, so the reservoirs, these are in the terminal world, these are the queues or the waiting areas or waiting lounge where passengers are hauled up to be processed to the next touch point. And the process is being controlled by the taps, and in this case are the resources in a certain touch point. So when we talk about the security area, the tap are the security lanes, and the more lanes I open, the faster the throughput of passenger is to the next resource. And then we have the routes. So this is typically how your airport layout is being maintained, that ensure that when one passenger goes through a certain touch point, then he knows where to go next, and this is controlled by the routes. So next to the things, next to the touch points and the resources, we can also measure all kinds of performances in this water system. So we can measure in a reservoir, in a queue, the expected wait times. We can measure at a resource, at the tap, the cost of operation. The more lanes we open, the costlier the execution, of course. We can also measure the crowd density, so how many people are in the same area at the same time. And we can measure, in the end, the total travel time or the total process time that a passenger took from entering the terminal until exiting the terminal. And once we have also these measurements in place, we can then start to make decisions. How many security lanes should I open? How many immigration jets should I staff? Should we maybe reallocate a flight to a different gate such that I redirect the flow of a certain group of passengers to another area of the airport? Or should I use different routes? So maybe I've sent some service agents into the terminal to redirect passengers to force them into a different part of the flow. So flow model, it's about taps, it's about pipes, it's about measurements. How can we apply this then in our day-to-day operations? And that I will show you, well, two ways how you can apply such a flow model. The first one is the monitoring of the flow, and the second one is optimizing the resource allocation. So let's first look into what we can do when we monitoring the passenger flow, where the capacity is given. So in this picture, I show how you could visualize the passenger flow, and you could call it maybe a heat map or anything else, but what it represents is that on the row of the table we have the different touch points, so the reservoirs or where the queues where people are being hauled up, and the cells of a row shows us the demand at that particular touch point within that particular time. So this says that there are 25 people in the waiting area before the security area A at 11:15. So this is how the visualization looks like. Now let's start showing what that happens when we get the input data. So like I said in the beginning, input to the flow model are the forecasted passenger demands. So not the forecasted passengers at each of the touch points, it's the forecast of when do we expect the passenger to arrive at the terminal. Then we can derive its route based on its first checkpoint. So typically that could be a check-in area, and we know which route the passenger has to take by its departing flight, for example. Yeah, so what we have now done is we have inputted the data for the forecasted passenger demand, and at 10:15 we expect 10 people to arrive at the check-in area. Since at the moment all the taps are still closed, so there are no resources available, that means that those 10 passengers are not being processed. So at 10:30 they're still at the check-in desk, and at 10:45 they're still there. So basically, as long as you're not processing the passenger, they stay within their current spot. At 10:30, again 10 people arrive at the check-in desk. So now the total demand here is 20. Yeah, so for each time window you can derive how many passengers will arrive at this particular touch point. Now let's start opening the tap. So we're going to open a check-in desk at 10:15. We will only open it for this 15 minutes, just to give you an example how then the passenger flows through the system. And so we're opening the tab, and based on the rules, 8 people were processed in that 15-minute time horizon. So 8 people were able to flow through the next touch point at security A. And there they are waiting again for the tab to open, and right now, since everything is closed, they will be waiting there indefinitely. From the first 10 people that were not processed, those 2 are moved to the next time window, the 10:30. So now at 10:30 there's 12 people again waiting at the check-in until the tab opens again. Yeah, so opening a tab means that a certain amount of people can be processed, and they can then go to the next touch point. So let's continue this process. Let's open a security lane in security area A. And within this 50 minutes, all 8 passengers were able to be processed, so they all flow to the next touch point. And again, they are waiting until a resource is being opened. So now let's continue the whole story. So we open immigration desk, so people are being processed to the next one. We open the shuttle service so that they can go to the lounge in area B. And in the lounge, they are waiting until the flight departs. And this way, by basically letting the passenger flow from one point to the other based on the available resources, and we can predict where each passenger is at a given point in time in our airport. So let's open all the tabs, which means in our world we are importing the resource plan at each of the different touch points, and then we get what we call a heat map. And so now we have capacity at all our touch points, and people are arriving and go through the system, and with the colors we indicate where a certain service level, for example, is being breached. So the demand is higher, the wait times are longer, there are too many people in a certain area. It could be anything, but it's based on how many passengers are at a given time waiting in a certain point. So if you notice that I put a line in there which has the now line. So this is a operational control view. So we are looking at the current time and up into the next maybe 24 hours or 10 hours, and we are updating the flow based on what's actually happening. So when a flight is being delayed, we are updating the demand. If a flight has been reallocated to a different gate, we are updating demand based on the flow model. So what we're looking at is an operational view of the expected demands in the next 10, 12, 2 hours, 5 days, depending how long we stretch this horizon. And this can be used by your controllers, by operational controllers, to find out where are my bottlenecks and to start suggesting changes in the resource plan. So in this case, we see a problem at the security, we expect a problem at the security area at 12 o'clock. So what we could do is we could ask for additional capacity. And when we do that, a flow model would then directly show if we increase capacity at security A, that means that the demand in our downstream processes will go up. And as long as it stays within a certain threshold, this could be a good decision, or maybe we need to do something else. So the flow model shows me the impact on my downstream processes when I'm starting to change the capacity at a certain touch point. Could also be working the other way around. So we see that we have a problem at our shuttle service. However, we can't increase that frequency. That's maybe we're already at max capacity, or whatever other reason, we are not able to change the capacity in this touch point. We can then look to our upstream capacity. So what if we increase the capacity at emigration? That means that passengers will be processed quicker and they will be moving earlier to the shuttle where we see there is still sufficient capacity. So increasing capacity in an upstream resource could lead to solving the problem in your downstream resource. Yeah, so that was about monitoring the flow, where we know the capacity at each of our touch points to identify bottlenecks in the foreseeable future, and to be able to make suggestions on how can we redistribute maybe the capacity, or should we reroute passengers, should we reallocate flights to gates. So all those decisions you can check in the flow model to see what the impact is. Another use for the flow model is to use it in your planning. So when we talk about optimizing the resource uses in all touch points, so basically determining how should I open the tab at security, at immigration, at check-in, what gate should I assign, so all those decisions optimized with looking at the passenger flow as the decision maker. And what we try to do here is, of course, we try to balance between the service level and the cost. If we open the tab at all touch points, we increase capacity to the max at all the touch points, then of course service levels will be highest, but we will have a lot of unused resources. And so it's about basically opening the tab just enough at each of these touch points in such a way that the overall passenger journey is being optimized. So again, we will need to have the forecasted passenger demand at the source as input to the system. We need to know the flight schedule and the resource and we need to know the flight schedule, but now we're not importing the available service level, the available capacity. We are, as input, we put in the target service level. So what do we want to achieve for our passengers? Could be within 1 hour, each passenger journey should be completed, so it should be all the touch points. Could also be more a point-based target service level. For example, I don't want to have longer waiting times at security than 10 minutes. And then the flow model could come up with a optimized resource plan that adheres to this target service level. Yeah, so in the end, by looking at all the different resources, it tries to optimize the passenger flow. So in essence, a flow model could be at the heart of your total airport resource management. Yeah. So there are many different departments, many different applications, many different stakeholders that all are planning their resources according to a certain demand. And what we are proposing here is that certain demand should be controlled in a centralized way, and a flow model could be the key to ensure that all the different stakeholders and all the different systems work together and are optimizing based on the total passenger journey. And so an example, at the security area A, you don't need to know what the complete passenger flow is. You would just get a suggested number of lanes from the flow model, and you adhere to those rules, although in your siloed world that might be looking contradictory. So that brings us to the end of this webinar. Let me rephrase the key takeaways, and I hope that I was able to explain the concepts and to show you how you could handle your resource management at the airport. So first takeaway, each resource decision that you make has an impact on your downstream processes at the airport. Using a flow model gives you the visibility of that impact. And once you have that visibility, you can then start to make smarter resource allocations to optimize the complete passenger flow in a cost-effective way. Before we go to the question and answers, allow me to give me a 1-minute introduction about who we are. So I'm a consultant for DELMIA Quintiq, and DELMIA Quintiq is a software brand for planning and optimization. So we use DELMIA Quintiq to optimize and plan resources at many different industries. So I myself am mostly working in the aviation industry, but if you look at our software proposal, and we deliver planning and optimization tools in logistics, in metals, manufacturing, maritime, and so forth. DELMIA Quintiq is part of Dassault Systèmes, which has actually 12 different brands of software in its portfolio. And you might recognize some of these brands like CATIA and SolidWorks for 3D design, but also Simulia for simulation and Excelite for data analytics. And they all come together in what we call the 3D experience platform. So with that platform, we are able to go to the next stage in the digitalization of the airport and looking at the digital twin of the airport. So that's so it's not just about planning and operating the airport, but it is all the way from the start of designing your airport, designing the layout of the airport, to then do the planning and execution of the airport using, for example, DELMIA Quintiq, to enhancing the airport by using data analytics and simulation, for example. So with that, I think it's time to move over to the question and answers. So Tara, back to you.
Thank you so much, Dirk. That was an excellent presentation. You're right, it is now time for our question and answer session. Just to let the audience know, you can still submit a question using the panel in the menu on the right. The first question that we're going to start with is, somebody has said here, we do not control the staffing of many of these touch points in our airport. How can we therefore use this information?
Yeah, that's a good question actually, because typically each of those touch points could be controlled by a different stakeholder, a different company even. So a good starting point would be to first to be able to monitor the flow, and then to suggest your stakeholders to improve their services. And so instead of just saying you need to open additional capacity, the flow model could help them to understand why this is needed and why they should adapt their resource plan in the light of the complete airport operation instead of their individual siloed worlds.
Amazing. Thank you so much. The next question we have here, as an airport, we currently use several point solutions for a variety of planning tasks. How does this solution fit in with those?
Mm-hmm. Yeah, so I would say the ideal world is that that through integration, for example, via an ESB, the data of these different systems is being fed as input to a flow model solution, and consecutively that the output of the flow model is then also sent back to the different applications. So that would be the ideal world. What you could also think of is that that the flow model is really imports the plans maybe manually or via an Excel import or whatever form you have this data available, and that you use it really as a monitoring tool where you make suggestions just by phone call, for example. You could call up the security department asking for additional capacity and then apply the changes yourself in the flow model to see the effect. And so it depends on your integration capabilities, how you could fit this in.
Amazing. Thank you so much. What user group will be using this application in the airport? Somebody has asked.
Yes, so that could depend on the scope you want to use it for. So first, the monitoring capability is really a solution that you could use, for example, in the control room. You could put it on a large screen so that it has everyone's attention, and you can start to respond to potential bottlenecks in the future. But if you look at the optimization of the resource plan, that is more that's more maybe the scheduling department, or depends on who is responsible for submitting the resource plans for a next flight schedule, the next day, the next season. So it depends on how you want to use this information. That would also determine who could use the application.
That's really interesting. Thank you. Somebody has asked, the data you need for an accurate prediction is typically owned by a variety of stakeholders. How do you ensure these stakeholders participate?
Sorry, could you repeat the question?
Yes, of course I can. The data you need for an accurate prediction is typically owned by a variety of stakeholders. How do you ensure these stakeholders participate?
That's a tough challenge, and that is typically the challenge for the airport, to have good communication with the different stakeholders, but also to give them, let's say, something back. So if they share the data, for example, an airline shares the data on the transferring passengers, and that allows you as an airport, for example, to provide better service for their transferring passengers, because you can then model them to the flow, and you can alert an airline, for example, when you see in your system that that connections are in danger. So typically it's a bit of a give and take. So you ask for the data, and what you give back is maybe a way to alert for misconnections, or maybe a way to smarter resource your security area, and so forth and so on. So basically it's a give and take game, and I think with the information that a flow model can generate, and you can give something back to the organizations or stakeholders where you're asking the data from.
Brilliant, thank you. Does your solution allow for integration with other planning applications we currently have in use?
Yes, I think that's similar to the earlier questions with, so yes, if you look at what DELMIA Quintiq can offer, we basically can, the integration can be with any type of system, but you could also directly integrate with the resource planning applications that we can provide ourselves. So it's either we can integrate with existing resource management applications, or we could offer the whole portfolio of both resource management and flow modeling.
Great, thank you. Someone from the audience has here asked, when an airport has huge capacity and less traffic, will it still benefit from such an approach?
So if capacity is not a problem. And then the only thing that the flow model could give you is to smarter staff your resources. So if you have 20 security lanes but you only need 2, then you should not open 20. But I think most benefit is, that we see is when capacity is limited, then smarter decision making could really create huge value. If there is enough capacity, then what could still give you a benefit in reduction in operational cost of that capacity.
Brilliant, thank you. Another question here, what is the difference with what you are proposing and passenger flow simulation?
Okay, that's a good question, and I think depends what everyone's definition is of the two. So in my eyes, when I think about simulation, it's really about simulating the behavior of passengers when there are, let's say, stochastic variables in the airport. So for example, a simulation you could use for what happens if there is a traffic jam, what happens for the passenger flow in my airport, or what happens if security area A has to be closed because of an emergency. How will passengers start to behave when that happens? Will they then all go to the other area? Will they be waiting? So it's more about simulating all types of different what-if scenarios. But typically, when you have such simulation models, they take time to compute. So you put in all the data, you put in the stochastic variables, you then run maybe 50, 100, 1,000 different simulations where you test it with the different stochastic variables, and then you come up with this is the best layout given that in 20% of the times scenario X happens or Y. So that's what my understanding is of simulation. Whereas what we're proposing is a model that can calculate in real time the effects of a delayed flight or the effects of opening additional resource on the flow of the passenger in operation, so at the now. And that's, I think, the main difference. The flow model is really for the operational control of the airport and make quick decisions, where a simulation model could be used to identify, for example, a new layout of the terminal building, or where could I better put the start of the queue? Is that on the left side of the area or on the right side of the area? So these are, I think, the different types of usage of a simulation and a flow model.
That's so interesting. Thank you so much. Another question here has come in. How can we introduce real-life limitations on the optimization? For example, security staff and border control work in shifts, so that might not be that flexible.
Mm-hmm. Okay, again, a good question. So the flow model it had basically two real KPIs. The one is the service level, so the passenger journey, and the other one is the cost. So in a simple world, just adding a security lane for 1 hour would contribute to 1 hour of additional work time cost. In reality, indeed, that looks much differently, because people work on shifts and cannot be called to work for just 1 hour. So those limitations, that is typically what you would configure in your model. So we are not saying there's one model that can work for all the airports. Actually, probably you need to tweak the models for each individual airport with their own limitations and their own restrictions to take these factors into account. That if you're opening additional lane, it doesn't mean 1 hour of work. It means I need to add 2 additional shifts of work. So these are the details that, of course, always come with implementing such decision support systems.
Brilliant. Thank you very much. Another question here. Can the solution be integrated with an airport's AODB?
Yeah, of course. So basically, there are no limitations to integration. And so we have done many implementations where we integrate with an AODB, for example, via the enterprise service bus of the airport. but basically there are various techniques that you could that we could apply to make sure that we integrate with the right systems, and AODB is one of those.
Brilliant. Thank you so much, Dirk. Unfortunately, that is all we have time for today. Any unanswered questions will be responded to via email. As you leave the webinar, a survey will appear on your screen asking you to rate the webinar. Please take a moment to do so. If now is not a good time, the survey will be sent to you shortly via an email. We would greatly appreciate it if you could complete this when you can. On behalf of International Airport Review and Dassault Systems, I'd like to thank you all for attending today's webinar. Goodbye.